So far in this course, the generic types we've created, we haven't done anything particularly interesting with those types. For example, in the buffer class, we have a write method that takes an argument of type T and stores a value in a queue, or it can return an object of type T from that queue, but there's no processing in between. We never try to invoke a method or read a property on that object of type T. We never try to create a new instance, and we have no restrictions on the type of T. It can be absolutely anything from object to a class that is 5 times derived from object. But not all generic types are so simple. Sometimes we need to interact with an object. We need to check if it's valid or if it has some value, or compare that object to another object. And that presents a problem. The compiler has to assume that T can offer nothing more than what we could get from a system.object reference. We can call toString on an object of type T, or get a hash code. Those are all methods defined on system.object. But what if we wanted to call a method like isValid before adding a value to the internal queue? The compiler won't like that. It doesn't know if T is going to have an isValid method. And if we're working with a buffer of double like we have been, well, a double doesn't include an isValid method. So without providing additional information, the compiler is not going to let us interact with an object of type T in our code. It's not going to let us interact with it as anything more than a system.object reference. And that's where generic constraints become useful, because generic constraints can force a type parameter T, or whatever it's named, to have certain characteristics or features. We can force T to be a class or a struct. That means it would have to be a reference type or a value type respectively. We can force it to implement an interface or derive or be a specific base class. We can also force it to have a default constructor or to derive from or be some other generic type parameter. I'll show you examples of all of these. The preview for the syntax is that this is all done using a where keyword when you define a generic type. After the where keyword, you can include the generic parameter name, a colon, and then a list of constraints that the parameter must meet. These can be one or more constraints. And to demo this, I want to leave behind the data structures that we have been using and look at another area where generics can be quite useful, and that is when building a data access layer. So let's build something using databases and some custom abstractions that talk to a database.